Well, I'm on top of the world looking at some gorgeous galaxies and nebula. Hey, everybody, Stargazer MarQ here, and so glad you've joined us at the American Space Museum. Our video podcast, Stay Curious, every Monday brings you backyard astronomy with me, Stargazer MarQ. I've been a happy amateur astronomer all my life. I have no memories of not having a telescope or loving astronauts in our beautiful cosmos. So we'll have got a little program here today about the spring equinox, why the first day of spring occurs at this March junction, like it did March 20th, Sunday, at about 11 o'clock in the morning, and what that means to the whole world in general. And also, why does Easter fluctuate from the beginning of April or March to the end of April sometimes? Well, that is determined, blame it on the moon, because it's the full moon that determines when the date of Easter is set. And we're going to explain that. And we'll end our little Star Curious on Stay Curious with using the Big Dipper as a guidepost to find a couple other constellations and bright stars in the sky, and an interesting little childhood saying that I have remembered all my life about using the arc of the Big Dipper handle to find two stars. So stick with us here. Welcome to everybody to another great week. Marty Winkle and I are beginning our second year anniversary of bringing you Stay Curious. We're going to celebrate that this week. And we wanted to bring you every Monday something about your backyard that you can see the stars. Here I'm a little bit above the world with this beautiful picture of our blue line, the only border that should really matter among us earthlings. And we also, as Nicole Stott, one of our astronaut supporters here at the museum, likes to say, we're just not passengers on this planet. We are crewmates. So we need to take care of each other like we have been the last couple years. So, Marty, let's kick this thing off with talking about. I love this old beautiful woodcut exemplifies what the mystery of the stars are to us, and how spring was a mystery, that the seasons happen in a very predictable manner. This was studied by ancient stargazers 3,000 to 5,000 years ago, and it took us till recently, the last 500 years, to figure out exactly what is going on when we look at this illusion punching our way out into the cosmos. Well, the Earth seasons, as I bring in our moon globe here, the Earth seasons are dictated by the tilt of the Earth. And it's very underestimated that something in knowledge that the Earth is, of course, not spinning straight up and down. It is tilted on its side, 24.5 degrees. That means something knocked us over. Okay, Mars is also tilted over on its side. The planet Uranus is tilted over on its side. It's like a bowling ball going around its orbit, all right? Without this tilt, if we were straight up and down, every latitude on Earth would experience the same temperate climate, meaning here in Florida, we would always be hot, or particularly up in the Midwest, where we've got a lot of Stay Curious, Star Curious friends in Michigan and Ohio and Indiana. They would experience the same probably 50-degree days and cloudiness every year without variance. But it's the tilt that does the work. And why? Because it's the same principle of getting a suntan. The rays of the sun are tilted away from the northern hemisphere is tilted away from sunlight in the winter months and tilted towards it in the summer months, okay? And in between the fall and the winter, it's about halfway, as we see there. Let me go to this next slide that's not pixelated out. Hello, spring. And boy, I know everyone's been waiting every year for it to thaw out, although a lot of people do enjoy the winter climate, and quite frankly, wintertime is a more clear nights probably in the winter than the summertime because of the summer clouds and storms. Well, here we are, Equinox 2022, and as you see, the winter solstice, we are tilted away, all right, from the sunlight. And as we go on the other side, our tilt, summertime, is towards the sun. The importance of that is the direct sunlight. And the best analogy is you do not get a suntan at 8 in the morning till 11 o'clock in the morning. The sun's rays are too long. There's no heat as the sun is low. But when the sun gets up higher, it's the same sun rays taking a shorter path, and they come straight down on top of you from 11 o'clock till 3 o'clock, and you can get burnt, all right? But you don't get a sunburn at 6 o'clock to 8 o'clock at night when the sun's up, all right? The sun is too low, and the heat from those rays is traveling through the Earth's atmosphere further distance, and it takes some of that hotness out of it. So the same principle of the globe of the Earth. Meanwhile, as we're celebrating the first day of spring, our friends in Australia are experiencing the first day of fall, unfortunately. Their winter is over. Now, here's another anomaly I bet you didn't think about. That you think that we're cold in the northern hemisphere, that we'd be further away from the sun during that time. No, we're not. We're actually closest to the sun around January 1st, when we're just 92,955,000,000 miles away, about 93 million miles away in January. In July, 4th, we are 95.5 million miles away. We're about 95 million miles away. The sun is an ellipse, but it's almost a perfect circle, but it varies from 93 million miles away to 95 million miles away from the sun. So that does not affect the heat of the Earth. The angle is what affects the seasons and the heat on the Earth, okay? Well, happy Easter, everybody, of course. Springtime, we think about Easter bunnies. The Christian holiday, of course, is on the minds of those people. And but it's not a religious holiday in one particular group of people. It has always been a holiday celebrated about the change of the earth, the equinox, by the way, equal day, equal night, okay, that's where that comes from. You have the spring equinox, and then in the fall you have the autumnal equinox. So yes, we're experiencing sunrise at about 7:30 and sunset at about 7:30. So that's a good thing to get out and do some things after work and so forth. Well, here's a picture of the moon to emphasize, a picture of the moon that I took to emphasize. I also want you to notice the feature on the right-hand side away from me. You have oceans on the left-hand side in more big mass, and on the right-hand side you just have a couple frozen lava seas, or maria, and you notice that oval on the upper right there. That's the Sea of Crisis. I want you to notice where those are when I show you another picture that's a fake picture. I'm going to alert you to a couple moon hoax photos that are always make the rounds, that people will go ooh and ah about, that are just completely photoshopped. But Easter, when do we figure out when Easter is? Why does it vary from March, first part of March, to the end of April? What's that all about? Why don't they just pick a day like we do for Christmas and say December 25th? Well, Easter, the date for it goes back to the Council of Chalcedon in 451 A.D., when Christian authorities devised the golden number in what they called, quote, the Sunday letter, to determine the date of Easter. And this, as you backtrack it, creates, when you set the date of Easter, that sets the date for Lent and your Fat Tuesday celebrations and so forth. It's all tied in to the first full moon of the spring, okay? And that first full moon of the spring has to occur after the first day of spring, which this year was March 20th. So it goes like this, folks. Here's a beautiful full moon, all right, taken by my good astronomy friend Steve Rissmiller, not too far up here from about 10 miles from where we're at, up in a community called Mims, north of Titusville. And you see that the little merism, the oval's at the top, because it's going to move as it moves left to right, and then that'll be the first object to set. But Easter is the first Sunday that occurs after the first full moon, which occurs after the first day of spring, or the spring equinox. All right, once again, you have to have the first day of spring, and we already had that. We had full moon Friday. Right, but that full moon Friday was was at March 18th, was before the first day of spring. The first day of spring is always going to be March 20th or 21st or 22nd, depending on some variableness of the Earth's tilt and its retrospect with the solar system in our orbit. That is defined as when the sun crosses the vernal equinox, all right, a place in the sky that's defined where the equator, all right, crosses with the Tropic of Cancer and the Tropic of Capricorn, the northern parts. So the sun is actually, as seen from Earth, is crossing directly overhead the first day of spring at the equator. So that said, it'll never occur. The first full moon on the March 18th doesn't count because that's before spring. So the first full moon we're going to have after the first day of spring, which was March 20th, occurs April 17th, 29 and a half days after the March full moon. So this is a late Easter, of course, and with the Saturday, April 16th full moon, Sunday, April 17th is our first day after Sunday after that to have Easter on April 17th. In 2023, it's going to be April 9th, 2024, March 31st, and on 2025, it'll be April 20th. So it's staying almost in April the next 4 years, okay? March 31st in 2024. So easy little thing to remember. It's a little more convoluted than that because you get leap years thrown in, and they alter it every 400 years or something like that because of the calculations. But here's a pretty picture of the full moon rising over the Atlantic Ocean that I took some time ago. And notice again, the upper right of the moon is where you've got the brighter highland areas, and the lower left and left side is where you've got the dark areas. The Mare are predominantly there. And I'm going to show you the next picture. Ooh, this gets oohs and ahs on the internet. You see dozens of pictures like this posted where the moon is coming up over the ocean and it looks like it's touching the ocean. This is a Photoshop. In fact, the moon image is flipped backwards because, as I've been showing you, the highland area is now at the top left, whereas it's at the lower right there. Here it's not. So they not only enlarge the moon in an inaccurate size coming over the ocean, showing the curvature of the ocean there and so forth, but they flipped it up backwards. So trust none of what you see and less of what you hear. Definitely. And this is not even that good of a Photoshop. If the moon was that bright, you would see the brightness lane coming down would be the width of the moon, okay? And not like a little bowling ball alley coming down there. So thank you, Bruce Jacobs, our IT guy, for sharing this with me. It allowed me to reveal a little bit of the moon hoax photos that you see all the time. This is one there that's not impossible. This is what the moon looks like, how big it is, okay? Coming over the Atlantic Ocean, another photograph I took a couple full moons ago, see? Very different. All right. Well, now that you know how an Easter is going to happen and you can get your bunny rabbit gifts ready here at the end for April 17th after the April 16th full moon, want to share with you the Big Dipper. The Big Dipper is not a constellation. It's what we call an asterism. But from your backyard, you're going to look at it, and it's going to be standing on its the curve of its handle, like you're seeing there. And you see in the center is the Big Dipper. It is just part of Ursa Major, the Big Bear. It's the hindquarters and the tail of the Big Bear. And the outer two stars point to Polaris, the North Star, which I've done a couple moon gazes the past week. And people are amazed to know that Polaris is not the brightest star in the sky. In fact, directly opposite at this time of year is the brightest star in the sky, Sirius. Polaris is not a faint star. You can see it from your backyard, but it's one of the fainter stars you can see from your backyard because it's second magnitude. And about third or fourth is all you're going to see from your backyard when you're staying star curious. So look at the Big Dipper, and you can use these other stars to point to other stars in the sky. And that's always a good guidepost to learn when you're learning astronomy and stargazing with your map, your celestial map with your planisphere that I've got for 8 o'clock tonight, March 21st, and my red flashlight to look at it so it does not, so my pupils stay nice and dilated and they don't contract down with white light. With red light, a red flashlight, put red cellophane over a regular flashlight, and it will allow you to read charts and things at night that you need to do to learn the constellations. And one of my very favorite childhood sayings that I remembered as a boy looking up at the stars for the first time was, you take the arc of the Big Dipper and you handle, and you arc to Arcturus and speed on to Spica. And here is a demonstration of you do just that. Follow the handle of the Big Dipper and you arc to a very bright yellow star called Arcturus. In Boötes, the herdsman, but it looks like a kite shape. And then you keep speed on to Spica. And Spica is a very white star all by itself in a big constellation, though, called Virgo. Virgo's the maiden. Virgo's thought of fertility, as well as Spica means sheath of wheat. That's what its name comes from. So it's thought of as an agricultural constellation, and it is a constellation of the zodiac where the planets and the moon dwell. So arc to Arcturus and speed on to Spica. And you'll remember that from your backyard, and you can find those stars very easily enough. And then with your binoculars on a moonless night, find a few treasures in there. There's a few open clusters in there, and we're starting to see some galaxies in Virgo. As the Virgo, when it rises, we're actually looking away from our center of our Milky Way galaxy out into a region of the stars that Corvus, the crow, is in that area up there. So arc to Arcturus and speed on to Spica. Go out and look from your backyard to the north, and you'll see the Big Dipper over on the east or to your right standing on its handle, and you'll see the bowl stars of it very easily. Follow the outside Dipper stars there to Polaris, the North Star. So there's another shout out to Polaris, you see, and Regulus, going back the other way, is higher up in the sky, and that is Leo the Lion. Regulus is the brightest star in Leo the Lion. So I always love seeing Leo in the eastern sky. It's a backward question mark with Regulus dotting its eye. And then the hindquarters of Leo is a right triangle. Very easy to see those two, a backward question mark or a sickle or a scythe like you would cut wheat grain with or weeds. And the back of Leo is a triangle. And we'll talk about Leo, the lion, next week when we talk about Stay Curious with the stars from your own backyard. So Marty, thank you for doing another great job as we've done a little more astronomy here on Stay Curious, being star curious. Here's another moon shot here in the beautiful palms of Florida. We hope everybody's warming up a little bit and getting outside. After all, you know, you can a good way to escape society in whole and all those reruns and TV shows is just going out in the backyard and enjoying a little peace and quiet, and with some binoculars or a small telescope, probe around a little bit with your red flashlight and find some stars for yourself. Because no one owns the original. You go outside, you can write a poem about it, take a photograph, make a sketch, or just contemplate philosophically the how, the why, and the when of this wonderful universe that we live in. That's available right from your own backyard. So thank you, Marty. I'm Stargazer Mark, and until next time, we hope to see you again with Backyard Astronomy on Stay Curious to bridge the space between us.